Good morning students, today is day 17. The chapter is relations and functions. As we have discussed yesterday, the concept of ordered pairs. So what is the ordered pair? Ordered pair consists of two elements in any fixed order. And next we discuss the Cartesian product of two sets. I just recall if A equals to 1, 2, B equals to 3, 4, 5. Then the Cartesian product is 1, 3, 1, 4, 1, 5, 2, 3, 2, 4, 2, 5. So this is the basic concept of the Cartesian product of two sets. So these are the subsets. So after that, if A cross B equals to A, B, C, D, E, F, G, H. If A cross B, this is the question, if A cross B equals to A comma B, C comma D, E comma F, G comma H. The question is find AB. Now what is A, what is B? A is the first elements A, C, E, G. A, C, E, G. Now B. The elements of B are small b, D, F, H. B, D, F, H. So in this way, from the elements we can find the Cartesian product of two sets, and from the Cartesian product of two sets we can find the values of A and B. Now we shift to the relation. So what is the relation? Denoted by R. So the relation R from non-empty set A. Non-empty set A to non-empty set B is a subset of Cartesian product of two sets, that is A cross B. So, for example, if A cross B equals to 1, 3, 2, 4, 5, 6, 7, 8, then we can write A cross B equals to R. So 1, 3, 2, 4, 5, 6, 7, 8. Now what is subset? The subset is derived by describing a relationship between the first element and second element of ordered pair. Of ordered pair in A cross B. So what is the relation? Relation R from a non-empty set. Remember one thing, in Cartesian product of two sets, the two sets must be non-empty. If either A or B, the one set is empty, then A cross B is also a null set. So a relation R from a non-empty set A to non-empty set B is a subset of. Now what is subset? Subset is derived by describing a relationship between the first element and the second element of ordered pair. This is a subset. So relation R from a non-empty set A to the non-empty set B is a subset of Cartesian product of two sets, that is A cross B. So we can write A cross B. This is the relation. The relation of element 1 with the 3. The relation of element 2 with the 4. The relation of element 5 with the 6. The relation of 7 with the 8. So this is the relation. These are the subsets, and the subsets is derived by describing a relationship between the first and the second element of a ordered pair in A cross B. Now remember one thing, the second element in ordered pair, it's called image. So the image of 8 is 7, the image of 6 is 5, the image of 4 is 2, the image of 3 is 1. And the first element in ordered pair we call pre-image. So remember one thing, the second element is called the image of first element, and the first element is called the pre-image of second element. Now we shift to the concept of domain, range and codomain. Domain. Now what is domain? So the set, first of all we will discuss the general form of domain definition. Then I'll explain you the concept of domain, range and codomain with the help of example. So the definition is a set of all first elements. The set of all first elements of the ordered pair in a relation are from set A to set B. Again, after that, range. The range is the set of all second elements of ordered pair in relation R from set A to set B. From set A to set B. The third one, codomain. Now what is codomain? The codomain is the whole set B. The whole set B is called codomain of relation R. So now we take an example. First of all, we take an example. If relation R is 1, 2, 2, 3, 3, 4, 4, 5, 5, 6. So, please listen carefully. Now A, this is B. Now, what is the relation? The relation of element 1 with 2. Relation of element 1 with 2. Relation of 2 with 3. 3 with 4. 4 with 5. And 5 with 6. Now, what is domain? What is domain? The set of all first elements of the ordered pair in a relation R from set A to set B. So domain is first elements 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. What is range? Range is the set of all second elements of ordered pair in a relation R from set A to set B. So the range is second elements, all second elements. So 2, 3, 4, 5, 6. The last codomain. Codomain means all the elements of set B. So all the elements of set B. So 1, 2, 3, 4, 5, 6. So this is the basic concept of the domain, range and codomain. I just repeat, what is the domain? Domain is the first element of all the ordered pairs. And range is second element of all the ordered pairs. What is codomain? The codomain is all the elements of set B is codomain. So from this we can conclude that range is always a subset or equals to codomain. So we can see the range, the elements of range are 2, 3, 4, 5, 6. All the elements of range are in codomain. So we can say range is a subset of codomain. What is a subset? When all the elements of one set is in another set. So all the elements of range are in codomain. So we can say the range is a subset or equals to codomain. So this is the concept of domain, range and codomain. Now we shift to the next question. Now we take another example. 1, 2, 3, 4. This is set A, this is B. This is A, B, C, D, E. Now relation R is 1, comma A, 2, comma D, 3, comma B. Remember one thing, we always find domain and range from the ordered pairs. Always find domain and range from the ordered pairs. So what is domain? Domain is all the first elements of ordered pair. 1, 2, 3. Range. All the second elements of ordered pair. A, D, B. Now codomain. What is codomain? All the elements of set B. A, B, C, D, E. So shift to the next concept. The next concept is total number of relations from set A to set B. What does this mean? The one more question, we have to find the total number of relations, or we can say find the total number of subsets. What is the same thing? So total number of relations from set A to set B, if NA equals to P, NB equals to Q, then NA cross B equals to PQ. So the total number of relations, the formula is 2 raised to power the number of elements in A cross B. So this is the formula to find the total number of relations from A to B is equals to 2 raised to power PQ. Now we take an example. A equals to 1, 3, 1, 2 and B equals to 3, 4. So how can we find the total number of relations? The question is find the total number of relations. Now first of all we will find A cross B. A cross B means 1, 3, 1, 4, 2, 3, 2, 4. So number of elements in A cross B is 4. Now total number of relations 2 raised to power 4, which is equals to 16. So in this way we can find the total number of relations. Now we shift to the exercise 2.2 NCERT. So NCERT exercise 2.2, the first question, A equals to 1, 2, 3, 4, 5 up to 14, and the relation is x comma y such that 3x minus y equals to 0. So now this is the condition and we have to find the relation. So the condition is 3x minus y equals to 0, 3x equals to y. Now relation, if we put x equals to 1, put x equals to 1. If we put x equals to 1, the value of y is 3. If we put x equals to 2, the value of y is 6. If we put x equals to 3, the value of y is 9. If we put x equals to 4, the value of y is 12. But if we put x equals to 5, this becomes 15, which is not included in A. Please recall, if we put x equals to 5, the value of y becomes 15, which is not in A. The elements of A are up to 14. So these are the possible subsets. Now we have to find domain. Now what is domain? Domain means first elements of all the order pairs. So 1, 2, 3, 4. Now range is all the second elements of ordered pair. So 3, 6, 9, 12. Then codomain means all the elements of set B. What are the elements possibles? 1, 2, 3, 4 up to 14. So this is the first question. In this question, from the condition, this is a condition, this is very important. This is a condition, we just put the values of x, these are the possible orders. From these possible orders, we can find range, domain and codomain.